So this is another question from IIT JEE PYQ. The question is from the chapter friction here. Here is the question. In the diagram, that blocks A, B and C are of mass 3 kg, 4 kg and 8 kg. So this mass is of 3 kg and this is 4 kg and this C mass is of 8 kg respectively. The coefficient of sliding friction between any two surfaces is 0.25. That is mu is equal to 0.25. It is given. Okay. A is held at rest by a massless rigid rod fixed on the wall. Okay. So this is a massless rigid rod here. Massless rigid rod. Okay. Right. And while B and C are connected by a flexible cord passing round on a fixed frictionless pulley. So this is rope here, and between A and this surface is rod, massless rod. Assuming that the arrangement shown in the figure, that is B on C and A on B as shown in the figure, is mentioned all throughout, the force necessary to drag C along the horizontal to the left at a constant speed. Okay, so here this force F we are applying on this block C, and it is given that this C should move with a constant speed. Okay, that means what? Its velocity is equal to constant. Since velocity is constant, so acceleration will be equal to dv by dt, that will be equal to 0. So here acceleration of the system is 0. Okay, so we just have to use the equation of motions here. Directly we can write. Now I will draw the free body diagrams for all of these bodies. Let me draw the free body diagram for this C mass now. So here is our C. This is C. Okay, and let me suppose this mass is 8 kg as given in the question, and we are applying a force F in the left direction. Since this body is having a tendency to move in the left direction, so due to surface there will be a friction force acting on it, that will be equal to, let us suppose we are calling it F1. Okay, and since this friction always prevents the relative sliding between the two bodies, so there will be a friction force acting on the upper surface also. Let me call that is F2. Okay, so here F1 force will be equal to mu into that normal, let me call it N1. Okay, and F2 friction force, that is mu into, let me call it, this is normal N2, right? So this N1, and here let me calculate the value of N1 here first. So let me suppose that this is the value of N1, and what is the value of N1 here? So N1 will be equal to the weight of these both masses A and B. Okay, so I can write N1 will be equal to MA plus mass of B into G. Okay, here G we have to use 9.8 meter per second square. Okay, so I can put the values of MA and MB here. So that will be equal to what? MA is 3 plus MB is 4 into G. I will substitute this value later. So that will be equal to 7G, right? Similarly, I can write the value of N2 here. What will be the value of N2? N2 is the normal force acting due to this surface. So since at this surface all of the weight is acting in downward direction, so N2 will be balancing mass of A plus mass of B plus mass of C into G. Okay, so it will be balancing all the weight of three bodies. So I can put the values here. Mass of A is 3 plus mass of B is 4. Mass of B is 4 plus mass of C is what? 8 into G. So that will be equal to 4 plus 3, 7 plus 8, 15. So it will be 15 into G, right? So here I can find out the values of that F1 will be equal to mu into N1, mu into N1, okay, that will be equal to 7 mu G. Similarly F2 will be equal to mu into N2, that will be equal to 15 mu G, right? So here I can write the equation of motion for this object, for this block C. Since it is having an acceleration that is equal to 0, so force on rightward direction will be equal to the leftward force. So force in the leftward direction is what? F, and that will be balanced by these two frictional forces, F1 plus F2. F1 plus F2, okay. So this F will be equal to what? 15 mu G plus that 7 mu Z, right? So this will be equal to 15 plus 7 and 15 plus 7, 22 mu G, okay. And one more force is acting in that leftward direction on this block C, that is the tension force due to this string, okay. So this tension force we can add in this equation of motion, that will be equal to plus T, okay. So here I can write plus T, so plus T. So this equation of motion for this block C will be equal to F is equal to 22 mu G plus this tension force. Let me call it equation number 1, right? Now I will be drawing the free body diagram for this block B. So here is our block B, okay. On block B there is a tension force acting in the rightward direction, and due to this tension force this body is having a tendency to move in the rightward direction. So to prevent this relative sliding, there will be a friction force acting in leftward direction due to this upper block contact. So let me call it FA, okay. Due to A block it is acting, so I will call it FA. Similarly, there will be a frictional force that is acting in leftward direction due to the contact in this block C, so that will be FC. So here, since this block is also having the acceleration is equal to 0, so I can write the value, the equation of motion, that will be equal to T, tension force will be balancing this FA plus FC, okay. Now I have to write these values of FA and FC. So what is the value of FA here? That will be equal to mu multiplied by normal force acting on this upper surface, that will be, let me call it NA, and FC will be equal to what? Mu into normal force due to the lower surface, that is, let me call it NC, okay. So here NA will be equal to what? The weight of body A is acting in downward direction here, so weight of body A is what? 3 into G. So NA will be equal to 3 into G, okay. Similarly NC will be equal to what? At this lower surface, at this surface, like here I will show you, at this surface how much weight is acting, that is equal to MA plus MB into G. So this NC will be equal to what here? NC will be equal to MA plus MB into G, and the value of MA and MB is what? 3 plus 4, okay. So this will be equal to 3 plus 4 means 7 into G, okay. So here the FA will be equal to mu multiply this NA, that is 3G, so 3 mu G. This is the value of FA. Similarly FB I can write, sorry, it is not FB, it is FC. FC I can write here, that will be equal to this NC multiply this mu, and value of NC is 7G, so that will be equal to 7 mu G, okay. So I can write this equation here, that tension force will be equal to what? Tension force will be equal to FA plus FC, that is equal to 7 plus 3, yani 10 mu G, 10 mu G. Okay, so I can substitute this value of tension in the equation number 1 here. That equation number 1 is what? F is equal to 22 mu G plus T. Okay, so F is equal to 22 mu G plus this tension force. So this will be equal to what? 22 mu G plus the tension force is what? 7 mu G, right? So here our force will be equal to 22 plus 7, that is 29. Okay, so it is equal to 29 mu G. Now we have to put all the values here. What is the value of mu? That mu is equal to 0.25. Okay, so 22 multiply 0.25 multiply the value of G is what? 9.8 we have to take here. So that will be equal to 29 multiply this 0.25 I can write as 1 by 4 multiply 98 divided by 10. Okay, so here I can cancel these terms. It will be 2 and it will be 49. Okay, so if we multiply these terms, 29 multiply 49 49 divided by 20, so I can cancel this also. That will be equal to what? 14.5. okay, so divided by 10, so this term will be equal to 1.45 multiply 49. Okay, when we solve this term, it will be coming nearly equal to that 71.05 Newton. Okay, so the value of force that is required to move this block C at an acceleration is equal to 0. That is equal to what? 71.05 Newton. Okay, so this is the answer for this question.